Okay, now I'll do one thing. Let me assume that one. So these are the initial conditions given. After some time, what is the state of elevator? It will undergo retardation. No? What is the ball? It will have accelerated motion. What is the acceleration of ball? It will be directed downward. No, acceleration of the ball will be directed downward. So nearby it, I'll show it. Due to weight, its weight will act. So I'll just assume a situation like this. Let the ball come and strike the elevator. Let the velocity of elevator be v. We don't know elevator velocity also. We are just assuming things. Nothing is there. So this will finally come and strike the floor. This is t equals 0. This happens after some time t. So let's get into the basic formula. So here I'll define position of ball with respect to floor. Floor I'll write F. Ceiling I'll write C symbol. And B is a ball. Okay, the position of ball with respect to floor finally minus position of ball with respect to floor initially. UBF T plus ABF T squared. Finally, they'll meet, no? Finally, they'll meet. So the final separation will be 0. Initial position, let me take this is that's equal to 0. I'll expand the formula, then we'll substitute all. We'll substitute all the things one by one. Position of ball plus 10. Anything directed upward, let me take positive. All the quantities, position, displacement, velocities, anything directed upward should be positive. Initial position of the floor will be at s equals 0 initially. So this will be this one. Initial velocity of ball minus 4. Initial velocity of elevator minus 20 t. Acceleration of ball minus g. Acceleration of elevator plus 6. Sir, all got negative. No, don't bother. Like if you want to take the direction as negative. So this will become minus 10. So this will be plus 20, 20 minus 4, 16t. 10 minus 10, 16 minus 8 t squared. Anybody value of t?
Sir, we got two values, sir, 20 by 8 and minus 4 by 8.
Sir, 2.5 and minus 0.
0.5 seconds.
2.5 and
Minus 0.5 seconds.
Yes, sir. 2.5 minus 0.
okay, clear? This one, the convention. So what do you mean by 2.5? I got positive value, no? I should take positive value only, not negative one, no? So it will strike the floor at after what time? After 2.5 seconds. So calculate the velocity of ball, no? So let's see that UB plus GT. So it will be positive. So it will be descending down. What about velocity of elevator? This is very important. UE minus 80. Why negative sign? A is upward, no? So A UE value 20 minus 6. This is 2.5. 2.5 will be 5 by 2. I'll get how much? This will be positive only.
Hi, sir.
5 meter per second. I'll write it below here. I think you can see very nice interpretation. No? The velocity of ball, it is 4 plus 10 into 2.5. So what is the velocity of ball? Will be 29 meter per second. And these answers are very important, the final. So this is our time. What direction the ball will be moving when it is striking the elevator? I think the answers will predict, no? When ball striking the elevator, in what direction the elevator will be moving. The answer I'm getting this, like a UE, what happened? I took UE as downward, no? This UE as positive here. So therefore the UE, what happened? The V is in the direction of UE. So therefore it will be moving downward. Earlier, you can see, I think you should not get confused. For this, the convention is what? The initial velocity. Yeah? So I think you have to come out of this particular convention. Here, the totally different convention we are using. The sign for the velocity is how to interpret with respect to initial velocity. Am I right? This is a really very good observation where student must make it. So like a earlier you took that UV all negative, positive, all that one. But look at here. The sign for VB, VF will determine the sign for VB, VF, G, and A will determine. It is determined by the initial velocities. Okay, no?
Okay, sir.
This one. So this is about the condition like this. Huh? Okay, can you work out other numericals if I provide? So
Yes.
I'll go for rain umbrella concept. Huh? Let me introduce to that today only now. This is about accelerated motion. Anything now I may introduce some condition like this also. After
Okay.
some time, VB and VF, V equation, what you wrote down are absolute velocity equation. Yes, with respect to absolute, no relative velocities these are. Still it's there. These are no relative velocities. They're absolute velocities. Okay, I'll start with the rain umbrella concept. Okay, now it's all about vector subtraction. Straight away, let me take you. If there's a position vector, R1 bar is there. And this is R2 bar. Initially, they are like this. And this is a resultant R bar. Or A bar, B bar, I'll write it. A bar, B bar. A bar, its magnitude and direction I'll keep as it is. If I increase B bar length, shall I call B1 bar? What do you expect the resultant? The new resultant, well, this is a new resultant, no? So let's compare all the angles also. Let's see that. Earlier what happened, the resultant was making angle theta. Can you anything say about the length? S, definitely R1 is more than R, no? By looking at the diagram only. So why it is? Because B1 greater than B. As B1 greater than B, is it fine? So therefore R1 will be greater than R. So if any magnitude of any one vector, if I increase or decrease, what will happen to magnitude of resultant? Has to change. And what happened to orientation? What happened to direction of the resultant? It should also change. Agree this? So theta 1 not equal to theta. Fine. So there's a vector diagram. What will be considering like this? So I'm going to take help of this idea in this particular thing. So there's a core idea. There's a core idea. Finish. Everything just revolves around this idea only. Okay, let's begin with so there's a person on the ground. There's a person on the ground. So here the rain is falling vertically down. here velocity of rain, let it be VR. The person is standing and is going to hold umbrella. Anyway, there's a rainy season. Those students finding very difficult. Okay, there's a rainy season is there. Directly take rain. Directly take the umbrella when it's raining. When it's raining, no, go and stand there. Finish over. What all I'm discussing is what you can manage there. Okay, there's a rain. There's a dome of the umbrella. So what is the state of person? Person at rest. So how we should hold umbrella? You should hold umbrella against the rain. No? What is VR? Velocity of rain with respect to ground. These are symbols. Velocity of rain with respect to ground. What is VRM? Velocity of rain with respect to man, this is. Then if I write VM, no, this is velocity of man velocity of rain with these are the symbols I'll be using. So what is VR? Velocity of rain with its. So if I'm how I should hold umbrella against the VR bar, not to get wet, and the size of umbrella matters. No, even the size of umbrella, you should be of sufficient diameter so that you should not get wet here. So now the person is in hurry, so he will start moving. So as he starts moving on the ground, so let the velocity of person so the man what happened will start moving. So let's take some values here. Let velocity of rain be 10 meter per second. Velocity of man with respect to ground also 10 meter per second. How we should hold umbrella? And with what speed the raindrops will strike him? This is the question. So I'll directly write the basic equation. VRM bar is equal to VR bar minus VM bar. I think it's over. VA bar minus VB bar. Your entire relative velocity is got over. So we have to calculate this VRM bar. So what is VR bar? VR bar is minus 10 J cap. Unit vectors negative y-axis plus 10 I cap. So this will be minus 10 I cap minus 10 J cap. Look at no minus 10 I cap minus J cap. How the resultant or VRM bar will be directed in the third quadrant, negative x-axis, negative y-axis, third quadrant it should be. So the rain water pen will be it will be directed in this way. So you put VRM bar like this. So this is the velocity of VRM bar. This is the angle. How much of angle? That will calculate this one. So how we should hold umbrella now? Now we should hold umbrella against VRM bar. You should hold umbrella. Okay, let this angle be theta. Fine. So let's come for the mathematical part. Okay, no. So let's check the mathematics. What is the mathematics here? Vector diagram will take it. So it'll be easy for you. So what that vector diagram? So it will be How is velocity of rain? Velocity of rain like this. Velocity of man minus Vm bar should be like this now, because Vr bar minus Vm bar. I'll shift Vr bar to the left now. So this should be the. So this is Vrm bar. So because see, what is the basic definition? Vrm bar, Vr bar minus Vr bar. No? So for Vr bar, I'll add minus Vm bar. So Vrm bar is coming in this direction. So let me take this is theta. So what is tan theta now? Vr by Vm. So this will be 10 by 10, 45 degrees. What is the velocity of raindrops? Magnitude I want. With what speed raindrops will strike umbrella? I think it will be 10 root 2. You can ask question, sir, are you sure that raindrops falling vertically down, they will wet him? No, they'll not wet him. Sir, if he holds umbrella, that one, the person what happened? He will hold umbrella vertically because the rain is falling vertically, though it is moving. Tell me what is the problem now? The rain will come from the front and it will wet him. You can really try all this. This will be wrong thing. Sir, like he wants to get wet, okay then. Better take out umbrella. Why to struggle so much? Not to get wet, this is a condition I'm discussing. To avoid wetting is what we are discussing. Okay, the dome of umbrella should be oriented against the VRM bar. So what is the basic necessity condition? For not to avoid wetting, the umbrella must be held against VRM bar. I think that there's the total idea of the entire numericals what we are going to discuss here now. So definitely what when he will get wet here. This is a wrong position. Nothing wrong. See, like he wants to get wet. So there's nothing wrong in this diagram. To avoid wetting, this diagram is wrong. Is it okay? So some books, that's why the books, they didn't discuss this because they say like, see, why you hold umbrella? To avoid wetting, no? So therefore, this particular thing, discussing this will be of stupid thing, according to science. So that's why the books totally avoid it. I'll also take it. So I should not. It's of no use, no, that one. So that's why I'll just take it out. So there's a one again, the condition which to avoid wetting, the umbrella must be held against VRM bar. Okay, now let's take the another condition. The man is in a hurry, and what you'll do, you will increase his speed. If he increases speed, then what conditions will arise? We'll see how we should like change the orientation of the umbrella. Clear, okay, all of you? So I think it's all about the vector diagram, no? The triangle of vector subtraction is what I'm holding. So what should be the orientation of umbrella? You should make an angle 45 degree with horizontal. Shall I go for next case?
Yes, sir.
Now he is in a hurry. Okay, I'll do one thing. I will. We'll compare here only. It will be easy for you to. Let's come for. So let him double the speed or say 2 VM. What are that? I will double the speed. Why double speed? Is in hurry. So we have to reach home earlier. So we will double the speed. Then we'll see what conditions will arise. So here is velocity. Let it be. I'll write VM1. 20 meter per second. The rain is going to continually fall vertically only. So VR is how much? 10 meter per second. Now, what is my question? How we should load umbrella and with what speed the raindrops will come and strike the umbrella? Directly, I'll enter into the VRM1 is equal to VR bar minus VM1 bar. VR bar minus 10 J cap. This will be minus 20 I cap. So what is the speed of the raindrops with which they'll come and strike the umbrella? 20 square plus 10 square. 400, 500, this will be 10 root 5 meter per second. With more speed, they'll come and strike the umbrella. Okay, let's go for vector triangle. So what is a vector triangle? So this will be VR bar. This is BM1. You see, I increase the size of the, or so magnitude of the vector is increased. No, so therefore, I should increase the length of the vector. So this is plus VM1 bar. Minus VM1 bar will be directed in this way. Let me draw the resultant triangle. Minus VM1 bar. Then this will be VR bar. This will be the new resultant. Oh. This angle, let me call theta 1. How to calculate theta 1? Tan theta 1. Let me show it here. So what is tan theta 1 will be? VR by VM1. So 10 by 20, 1 by 2. Anybody value theta 1? 0.5. Anybody just give the value? VRM1.
Sir, nearly 26 to 30.
20, yeah, 26 degrees. Huh? I'll write it down. So I think earlier how much it was angle? The theta was 30 degree, no? Here. This theta was 45 degrees. Now what happened? Theta 1 26. So you should tilt more towards him or away from him. You should tilt less away from him, no? Or you should tilt more away from him. So this will be the stick of umbrella.
More, sir.
You should tilt more.
So what happens if we hold vertical?
What happened? Let me finish off. I'll address you. So this was the theta one, no? And the theta one, you can show it theta. Yeah, this will be. This was a theta, no, earlier. So now this will be theta one. Somebody asked, sir, vertically, definitely, I'm very sure, sir, raindrops will come. No, the raindrops will come along the red color arrows only. Provided the diameter of the dome should be sufficient. Is that okay? No. So what you should do? You should orient his umbrella against VRM bar. That's all. Finish over. Now what happened? You should tilt away from earlier. What happened? What was the angle of tilt? 45 degrees with vertical. Now what happened? You should tilt away from him. No. Theta 1 20 90 minus 26. You take it. 64 degrees. So earlier, what was the angle with respect to vertical? 45. Now it should be 64. You should tilt away from him. Or you should tilt less. You should tilt towards the ground. So the mathematics is what we are predicting. See, why we are bringing sir rain umbrella? Is it really so worth? You just go back to the aeroplanes, no? Just some 1930s, 1920s, 1910. I think from 19th century onwards, you can go for it. We had open cockpit, no? The cockpit was open. Only the windshield it used to be. So when the plane is moving with the velocity, the wind velocity will come, and the velocity of plane, wind velocity. So how that windshield, the windshield what will protect the pilot from ejecting out. So you should orient his windshield. For that purpose, these things are brought. So how you should, the pilot should orient his particular windshield against the velocity of wind with respect to plane. There, that necessity was arise. So therefore, the pilot what you should be very good in all this relative velocity. You should be trained. So now what when the cockpits are closed, totally that one. So the effect of wind on the aeroplane speed is negligible nowadays. The technology has got improved, but earlier if you go for the earlier conditions, no, it was really the pilot development should be in a sir, VRM will never be parallel to VR. If man is at rest, then VRM will become VR. When man starts moving, no, then no question of VRM becoming parallel to VR. Okay, then after this, where the necessity, like the cars, no, it used to be earlier the cars were open, there was no cover. So for that purpose, what will happen? There also the windshield should be adjusted properly. Even you can see the hailstones. I don't know in Telugu what you call hailstones. They're called as some small ice blocks. They're called as hailstones. Rainy season, no. That too, in the beginning of rainy season, this hailstone rain will come. This one. So small ice blocks instead of rain, no, you'll get this ice blocks. That one. So when they are striking that windshield, no, so how to protect yourself? So if the hailstones, if the windshield is directed against the velocity of hailstones with respect to car, then you'll protect yourself, no. So there, this necessity was there. That's what when they brought this particular thing. Okay, now we have car totally covered, aeroplanes totally covered with. In very few applications, this will be using now. Got the idea? I think somebody asked some doubt. Let me clarify. Okay, now we'll take one more situation. Today I'll upload assignment. But today, sure, I'll upload assignment because we are. I was not very sure about what will be the schedule, so I was waiting for schedule. Okay, no, I'll give one more. We'll go for one more case. The rain is falling with a, now let the rain come at an angle theta. This is VR, and this would be the velocity of person. So let the velocity of rain be 10 meter per second. Theta, let it be 30 degrees. So let me give the velocity of man. Let it be 4 meter per second. Let it be 10 meter. Let it be 18 meter per second. For these velocities, what will be the orientation of umbrella? So what are the cases for velocity of man? First case we'll discuss. And the first case we are discussing now. Let it be 6 meter per second. How we should orient is umbrella. And what is the velocity of raindrops? Second case will make it more than that, equal to that. Okay, work out now. When is a test, how we should hold umbrella against VR bar. When it's moving open, how we should hold umbrella. This is a question. Second case, we'll bring it here. Second case, directly let me go for VM1. Yeah. I'll do one thing. I'll give velocity V1 like this. It'll be easy for us. V2, let it be. We'll make it more than that. And how we should orient is umbrella. Straight away, define first VR bar. Can you resolve this velocity vector VR bar? It will be 10 sine theta I cap, 10 cos theta j cap. Sine theta, sine 30, 1 by 2 I cap, 10 cos 30, root 3 by 2 j cap. So this is the velocity of rain with respect to ground. Let's keep here. Now what is the velocity of man? It is how much? 6 I cap meter per second. Okay, directly calculate now. We are shall I write VR1? So VR bar minus VR bar. So VR bar is how much? 5 I cap, 5 root 3 j cap. VN bar, V1 bar, it is 6 I cap. Five minus 6, it will be minus I cap, minus 5 root 3 j cap. So how we should hold umbrella? So this, I'll go for the vector, minus I cap, 5 root 3. And this should be the velocity of rain with respect to 1. So let me just take this angle theta 1. So what is tan theta 1? Should be equal to 5 root 3 by 1. Anybody value? And what is the value of VR1? VR1 is equal to 1 plus 5 root 3 whole square. So root 76 it will come. I think all this we discussed in vectors. I told you like vectors is something very best, like it's a very fundamental chapter where the ideas you're going to apply it. Anybody value?
Sir, you are calculating these angles with respect to what axis?
Theta with respect to horizontal theta. Here it'll come, no?
Sir, 83.4.
83.4. Okay, thank you. 83.4 with respect to horizontal. I'll show it here. So the raindrop will come like this. So I should hold umbrella. This will be really troublesome for students. Like, sir, how the rain is coming and how he's holding umbrella. What is this like? I'll write it. Let me put the value here. 6 meter. You should hold umbrella like this, you see. So that 83. So this is what with what is the theta 1? Theta 1 what we calculated, you know, with this one. Okay, all of you just make some good observation. Rest of everything already you know, basic maths. The rain is not coming. There's a rain. There's a direction of rain. Direction of rain with respect to ground. There's a direction of rain with respect to man. I think a lot of confusion is there. So I'll give one more diagram. When is at rest? How we should hold umbrella. This is theta, you call it. So the person is here. He is at rest, is not moving. How we should hold umbrella? He should hold umbrella against the VR bar, no? Okay, now see the, look at the diagram, compare both. When man is at rest, he should hold umbrella against VR bar. There's no other way. When he's moving, no, he should hold umbrella like this, VRN1, VR1. Are you looking at the words rest? I brought clearly rest. Man is not moving. So let's not bother VR bar when it's moving. Against VR1 is what the umbrella should be held. Because what is the velocity of person? V1, no? Against VR1. Getting the idea, no? Sir, like, are you very sure? I think its back will get wet. No. If he is moving, if he holds umbrella against VR, what is the problem? The VR1 will come and wet in front. I think this happens when you are moving on bike, no? Sometimes when you are riding the bike in rain, no? Sometimes your front part will be wet, your back part will be dry. Or sometimes your back part will be totally wet and front part will be dry. Any reason for that? because of this condition. If you're not having umbrella, tell me like which part will be wet? Front or back part? The front part will be wet. Back part will not be wet. Without umbrella, the person is running with speed 6 meters per second. Then what happens is the front part will be wet. The back part what happens will not wet. The raindrops will not strike is striking behind. So when it's at rest, umbrella should be held against VR bar. When it's in motion, the umbrella should be held against velocity of rain with respect to man. Finish over. Nothing big. This much clarity is what you should need. This is the first case. Tomorrow I'll continue with the remaining cases. So velocity of man. Okay, all of you getting some. So I think I'll show that triangle. And now you can ask me, sir, what about the triangle, sir? You didn't draw a triangle. So let me bring the triangle also. So this is the VM1 bar or V1 bar. And this is what that VR bar, no? So minus V1 bar should be like this. So now you can see clearly. This is what that V1 bar, no? And this is what VR bar. How the resultant will come? Resultant will come like this. Oh. See now, look at least, look at this triangle, minus V1 bar it is. Tell me like which position you will feel very comfortable in holding umbrella. Vertically, no? So what you should do to hold umbrella vertically. Those cases we'll discuss tomorrow. Some here kids like I'll just poles is there. How many of you are able to log in ePregna? I think all of you got the answers. Question something display. The 12-meter case I'll discuss tomorrow. Okay, all of you, any poll, did you get it?
Sir, wait, sir.
Oh, you're not able to see the poll. Huh? How many of you are able to log in ePregna? Something I asked question. So in poll, actually it should display for you. Not there. Huh? Okay, I'll make it no. Did you got anybody?
Sir, should we log into ePregna, sir?
No, not like see, like when you are using the ePregna website, are you able to log in very easily or not? I'm asking that one. If you say
Yes, sir.
yes, you just type it S and send it that one. All are able to say S, no, S, no. if you're unable to log in, say no. If you're unable to log in, say yes. Huh? It's everyone who are able to log in very easily. Everything, no technical problem, say yes. Who are having problem with the login, no, say no. Is it okay? Just upload yes or no, that one, huh? Based on your. Everyone, if you are able to log in properly, not don't check now ePregna. So yesterday or day before yesterday, you are able to log in ePregna or not. If you're unable to log in, any problems, if unable to log in, say no. If you're able to log in, say yes. Because like some students like a complaint like we are unable to log in, no? So who are able to log in, who are unable to log in, no? If I'll gather that information, I'll submit to principals. Yes, I think 72 strength is there, only 30 response I got, remaining all say yes or no. You're able to log in, say yes. In the chat, you can tell it no, yes or no. In chat, you can say yes or no. All of you, just say yes or no, so that I'll save the chat. Don't send me in WhatsApp. Say in chat. Don't send me in WhatsApp. In chat only, you can say yes or no. Yes, no, no problem. Anything. 72 responses. Still, many are not responding. Huh? Okay, assuming that nobody is having problem.